The production of 48,386 vehicles in Q1 2026 is only the beginning of a much bigger transformation happening at Geiger, Texas. Behind this progress are technologies like the massive 50,000-ton gigapress, Tesla's unboxed manufacturing process, and next-generation LFP batteries that could dramatically reduce costs. Tesla is not simply competing in the EV market anymore. It is attempting to completely redefine how vehicles are designed, manufactured, and produced at massive scale. The question now is whether traditional automotive giants in Detroit and Germany can adapt quickly enough, or if they will find themselves unable to compete with Tesla's new manufacturing approach. You may have heard about Tesla's Cybercab and the unboxed manufacturing system, but the real importance goes far beyond a new vehicle. When Cybercab moves into large-scale production, the 50,000-ton gigapress represents a completely different era of automotive manufacturing. This machine applies around 50,000 tons of force, equal to roughly 50 million kilograms, to shape molten aluminum into large structural components. Compared with the 6,000-ton presses used for Model Y and the 9,000-ton system developed for Cybertruck, this represents a massive increase in manufacturing capability. Instead of producing hundreds of smaller pieces and connecting them through thousands of welds, Tesla's approach allows major sections of the vehicle structure to be created as a single piece. This dramatically reduces complexity, lowers production steps, and simplifies the entire supply chain. Traditional vehicles often contain hundreds of stamped parts that require welding, transportation, and assembly from multiple suppliers. Every additional component creates more opportunities for defects, higher costs, and greater logistical challenges. With giant casting technology, Tesla can eliminate many of these steps. Large aluminum sections can be created in one process, reducing dependence on traditional suppliers while increasing control over manufacturing. However, this does not mean the system has no risks. When production depends heavily on one massive machine, any failure could create major disruptions. A problem with the gigapress could potentially stop an entire production line instead of affecting only one small section of manufacturing. Large-scale casting also introduces technical challenges. Small imperfections such as air pockets, uneven cooling, or tiny cracks could damage an entire structural component. Unlike traditional manufacturing, where individual parts can sometimes be replaced, a large casting either meets quality standards or must be discarded. Tesla is accepting these risks because the potential benefits are enormous. The company's goal is not only to build cars, but to create a highly automated production system capable of supporting future autonomous transportation. The gigapress becomes even more powerful when combined with Tesla's unboxed manufacturing method. For more than a century, the traditional moving assembly line introduced by Henry Ford has dominated the automotive industry. Tesla's unboxed process attempts to completely rethink that model. Instead of building a vehicle step by step on a single production line, Tesla divides manufacturing into multiple sections that are built simultaneously. Major modules such as the front structure, rear structure, battery pack, and interior components can be prepared separately before being combined at the final stage. This approach allows robots and workers easier access because the vehicle structure is not treated like a closed shell during assembly. Robots can operate from multiple angles, improving automation efficiency and reducing manufacturing limitations. The process is similar to building different parts of a computer at the same time before assembling the final system. Tasks that previously had to happen one after another can now happen in parallel, saving time and reducing factory space requirements. One of the biggest changes is how the interior is installed. Instead of workers reaching inside a completed vehicle body to install seats, carpets, and other components, Tesla's system allows these parts to be prepared separately and placed into the vehicle during final assembly. This reduces complexity, prevents damage, and allows components to be tested before installation. The combination of giant casting and unboxed production could allow Tesla to create factories that are smaller, faster, and more efficient than traditional automotive plants. Tesla is not just improving the assembly line, it is questioning whether the traditional assembly line is even necessary. The company's vision is a manufacturing system where vehicles are produced more like a highly optimized industrial product rather than being slowly assembled through hundreds of individual steps. As Tesla continues developing this approach, the biggest challenge for traditional automakers is clear: if a competitor can build vehicles using less space, fewer parts, and fewer production steps, how long can older manufacturing methods remain competitive? Tesla's manufacturing revolution is not limited to casting and assembly. Another major part of its strategy is battery technology, especially the development of next-generation LFP batteries designed to reduce costs while improving performance. Tesla has been working to strengthen its battery supply chain by expanding partnerships with multiple suppliers and moving toward greater control over cell production. Instead of relying heavily on complete battery modules from external companies, Tesla aims to source advanced prismatic LFP cells directly, giving it more flexibility in production and cost management. The biggest improvement comes from the third-generation LFP battery design. Unlike traditional cylindrical cells, prismatic cells use a rectangular shape that allows battery packs to use space more efficiently. More active material can be placed inside the same area, improving overall pack efficiency without dramatically increasing cost. The internal chemistry has also been improved to reduce resistance and increase charging performance. These upgrades could allow future LFP batteries to support much faster charging rates compared with older versions. A major advantage of this technology is charging speed. Traditional LFP batteries often operate at lower charging rates, but newer designs could potentially support around a 3C charging rate. In theory, this means a battery could recharge significantly faster, bringing charging times closer to the convenience level of premium battery technologies. For affordable electric vehicles, this improvement is extremely important because charging speed has always been one of the biggest concerns for customers. Faster charging makes lower-cost EVs much more practical for everyday use. Another strength of advanced LFP chemistry is charging consistency. High-nickel batteries can achieve impressive peak charging speeds, but that speed often decreases as the battery fills. LFP batteries generally provide a more stable charging curve, maintaining reliable performance across a wider range of battery levels. This means drivers may experience more predictable charging instead of seeing performance drop sharply after reaching a certain percentage. Thermal stability is another major advantage. LFP batteries are naturally more resistant to overheating compared with some other chemistries. This reduces the need for complicated cooling systems, lowers manufacturing complexity, and improves long-term reliability. Because fewer cooling components are required, Tesla can simplify battery pack designs, reduce weight, and lower production costs. When these small improvements are applied across hundreds of thousands or millions of vehicles, the savings become significant. Battery lifespan is also one of LFP's strongest advantages. While some high-performance battery chemistries may experience greater degradation over time, LFP cells can often handle many more charging cycles before losing significant capacity. This makes them especially attractive for Tesla's lower-cost vehicles, robotaxis, and high-mileage applications where durability and total ownership cost are critical. However, the battery race is becoming increasingly competitive. Chinese manufacturers have already introduced advanced charging technologies that push beyond current LFP capabilities, with some companies developing batteries capable of extremely fast charging. This shows how quickly battery technology is evolving. The industry is moving from improving charging times from around 40 minutes to 20 minutes, and eventually toward charging speeds that could take only a few minutes. For Tesla, improving LFP technology is not only about reducing costs today. It is also about staying competitive in a rapidly changing battery market where future breakthroughs could determine the leaders of the electric vehicle industry. When combined with Tesla's manufacturing innovations, cheaper and more efficient batteries could allow the company to produce millions of affordable electric vehicles while maintaining strong margins. The larger goal is clear: create a complete ecosystem where battery technology, automated factories, and vehicle design work together to make electric transportation cheaper, faster, and easier to scale globally. Tesla's future strategy goes far beyond simply producing electric cars. The company is building an entire ecosystem around autonomous transportation, artificial intelligence, and large-scale manufacturing. The combination of advanced factories, cheaper batteries, and automated production could allow Tesla to move from producing hundreds of thousands of vehicles to millions at a much faster pace. The Cybercab represents a major part of this vision. Instead of being just another vehicle, it is designed as a platform for autonomous mobility. With improvements in manufacturing efficiency and self-driving technology, Tesla aims to create a future where transportation becomes more affordable and accessible. The company believes that reducing production costs is the key to expanding adoption. By using fewer parts, simplifying assembly, and improving battery economics, Tesla can potentially bring down the cost of electric vehicles while maintaining profitability. This approach puts pressure on traditional automakers. Companies that rely on older manufacturing systems may struggle to match Tesla's speed, automation, and cost advantages without completely redesigning their factories. However, Tesla's aggressive manufacturing strategy also comes with challenges. Scaling new technologies is never simple. Production quality, supply chain reliability, software development, and factory efficiency must all improve together. A breakthrough design means little if it cannot be produced consistently at massive scale. Battery competition is also becoming stronger. Companies around the world are investing heavily in faster charging, cheaper materials, and improved energy density. Tesla will need continuous innovation to maintain its position in an industry that is changing faster every year. Despite these challenges, Tesla's advantage comes from combining multiple technologies at the same time. The company is not only building vehicles, it is connecting manufacturing, artificial intelligence, robotics, and energy systems into one integrated platform. The future of transportation may not be decided only by who builds the best car, but by who can manufacture millions of intelligent vehicles efficiently and affordably. Tesla's Gigapress and boxed manufacturing system and next-generation battery technology represent a completely different approach to automotive production. Instead of improving small parts of the old system, Tesla is attempting to redesign the entire process from the ground up. If this strategy succeeds, the impact could extend far beyond Tesla. It could force the entire automotive industry to rethink how vehicles are designed, built, and delivered. The next few years will reveal whether Tesla's vision becomes the new standard for manufacturing, or whether traditional automakers find a way to catch up. One thing is certain: the competition in the electric vehicle industry is no longer just about making better cars. It is about creating the fastest, smartest, and most efficient production system in the world. Thanks for watching. If you enjoyed this video, make sure to hit the like button and subscribe for more updates on Tesla, electric vehicles, artificial intelligence, and the future of technology. Let us know your thoughts in the comments below. Do you think Tesla's new manufacturing approach will completely transform the automotive industry, or will traditional carmakers find a way to catch up? The future of transportation is changing faster than ever, and we'll continue bringing you the latest developments. See you in the next video.